Let me give you a quick overview before we begin. We're going to build a full minifigure pipeline from Blender to Unreal Engine, including rigging, materials, stickers and animation. I try to keep everything as simple and practical as possible, so you can follow along without getting lost in too much theory. To do so, go to my Google Drive and download the Lego Minifigure to UE5 folder. It contains everything you need to create the rig. With that out of the way, let's get started. First, we need a minifigure mesh from Mecabricks. Go to the workshop and assemble it using the same parts I am using, otherwise your UVs might be different later. When you're done, go to File, Export and choose Blender addon.zmbx as the format. You will also need the Blender Lite add-on from the Mecabricks store, so Blender can import the minifigure correctly. Now switch over to Blender and open the provided Lego minifigure.blend file. For game engine workflows in general, it is important to set the unit scale to 0.01. That way your assets will be of the correct scale when exporting to Unreal. To install the Mecabricks plugin, go to Edit, Preferences and Add-ons, then click the little arrow in the top corner and choose Install from Disk. Select the blenderlite.zip file and install it. After that, you'll find a new option below File, Import mecabricks.zmbx. Use that to import your minifigure. Perfect. Now we need to optimize the mesh so it works properly in Unreal. I created a script that automates most of the process so you don't have to do everything manually. Go to the scripting tab and open the file called mecabricks_ue_pipeline.py and run it. This adds an additional helper window to the sidebar where you can select all parts of the minifigure and run the cleanup process automatically. Finally, move the mesh to the rig collection so that the entire rig is in a single place, which is important for animation later. We can now set up the rig. First select the mesh, then the armature. Press Ctrl P and choose with armature deform. At this point the mesh is connected to the skeleton. Now select both the mesh and the rig and export them as FBX. There are a few export settings we need to change so Unreal can import everything correctly. Important settings are setting smoothing to face, armature FBX node type to root, only deform bones to enabled, add leaf bones to disabled, and for animations also disable all actions so we can export animations individually later. For the sticker system in Unreal, we're using a UDIM setup. That basically means every body part gets its own UV tile in a 3x3 grid. This allows every part to have its own sticker texture while still using only one material in Unreal. Now let's move over to Unreal Engine 5. When importing the mesh, go to the build settings and disable recompute normals and recompute tangents. Also disable import materials and import textures. Then import the mesh. Next, import the default sticker set by dragging the first texture into the content browser. Unreal will recognize the naming convention automatically and import the whole texture set as a virtual texture. After importing, apply paper 2D texture settings, which helps to avoid compression artifacts. Now create a new material called m_minifigure, open it, drag the t_minifigure texture into the graph and connect it to the base color. Right-click the texture sample node and convert it to a parameter so we can switch the texture set for a new character later. We also need a texture coordinate node so Unreal uses the correct UV channel for the stickers. To create a new character, we first need a set of sticker textures. Luckily, Mecabricks already provides them indirectly. You can either browse the minifigure library or create one yourself in the workshop. When exporting as Collada, you'll get a .zip file that contains the textures. Organize them in a single folder and make sure that you use the correct UDIM number at the end of every file, otherwise Unreal won't be able to recognize them. Make sure that every texture is fully colored. So if you see a texture with transparency, you need to add a background color manually using an image editor. Even though the hands have their own UV space, they are usually just a single color. So you can simply create blank textures with the color you want and use that as your sticker. One important thing to watch out for is the UV layout. The minifigure uses very specific UV spaces for the stickers, so the texture needs to match that exact layout. Otherwise it won't line up correctly on the model. So either find textures that already fit the UVs, or adjust them yourself in something like GIMP or Adobe Photoshop. Whenever you want to create a new character, simply create a material instance from the master material and assign your own texture set. Now you can drag the mesh into any scene, assign the correct material instance, and your character is ready to use. If you downloaded my Lego plugin for UE5, you'll also get access to a full library of extra parts like hair, hats and accessories. If you want a persistent character setup, I'd recommend creating a blueprint actor, pawn or character and assembling everything there. But what you do with the minifigure after that is really up to you. The last thing I want to show is how to animate the minifigure in Blender. Create a new scene, set the unit scale to 0.01 and adjust the viewport clipping distance so you can actually see what you're doing. Then go to File, Link, select the minifigure.blend file that contains the rig, open the collection folder and select rig. This links the rig into your new scene, which is a common way to separate the animation file from the original rig file. Right now the rig is locked and you cannot go into pose mode. To make it editable, go to Object, Library Override and Make. Now you can enter pose mode and start animating. Animating for games is a bit different from animating for movies. Game animations usually run at higher frame rates like 30 or 60 frames per second instead of the 24 frames per second commonly used for film. Animations are also usually split into short clips like idle, walk or run. To create animations like that, switch the dope sheet to Action Editor, now press New and create an animation like A_walk. And after all this setup work, you can finally start animating. Once your animation is finished, change one of your viewports to the Nonlinear Animation Editor. This is where we store finished animations before exporting them to Unreal. You'll see your animation listed there already. Click the little icon to push the action down into the NLA stack. That marks it as ready for export. Make sure you're still in pose mode, then export everything as FBX using the same export settings from before. Name the file after your animation and switch back to Unreal one last time. Inside Unreal, drag the animation FBX into the content browser. In the import window, select the minifigure skeleton as the skeletal mesh. Press import and that's it. You now have a fully working Lego minifigure animation inside Unreal. Hopefully without problems. There are probably 1,000 things that can go wrong with a setup like this, and Blender's nonlinear animation system can definitely be annoying sometimes. There are also a lot more edge cases and problems you'll probably run into while animating like this, but covering everything would make this video way too long. So if something breaks, hopefully we can figure it out together in the comments. I still hope this video covers most of the important steps needed to start working with Lego minifigures in Unreal. As you can see, it is definitely not the easiest workflow in the world, but I think this setup is good enough to start experimenting and building prototypes. Anyway, thanks for watching and have fun building your own Lego world in Unreal.